Hi guys, welcome to Miracles Library. So in this channel today we'll be talking about atomic structure. Before we go into the video, I would love you to smash the subscribe button and turn on the notification bell so that anytime we post a video here on YouTube you will be notified. Atomic structure. The atomic theories propounded by John Dalton in 1808 are as follows. All elements are made up of small visible particles called atoms. Atoms can neither be created nor destroyed. Number 3. Atoms of a particular element are exactly alike and different from atoms of all other elements. Number 4. When atoms combine, they do so in a simple ratio. Number 5. All chemical change results from combination or separation of atoms. Criticisms of Dalton's atomic theory. Number 1. The discovery of subparticles like proton, which is the positive charged electrons, and the electron, negatively charged, and the neutron, which has no charge, led to the nullification of the first theory, and hence atom is divisible. Number 2. Physical reaction disproves the second theory since atoms can be created or destroyed on physical reaction. Number 3. Isotopy also nullifies the third theory. Some scientists like J.J. Thomson, Rutherford Bohr, and many others worked very hard through their various experiments to describe the structure and arrangement of atoms. Structure of an atom. So this is the structure of an atom. You can see the electron and the nucleus. The nucleus is the proton plus the neutron. That is it. So now let's explain the proton, the neutron, and the electron. The proton is a positively charged atom which is located inside the nucleus. The electron is a negatively charged atom which is located outside the nucleus, while the neutron is a neutral atom, meaning it has no charge and is located inside the nucleus. Quantum numbers. There are 4 quantum numbers, which are: number 1, the principal quantum number. It is noted by n and determines the energy levels of the atoms. Note: maximum possible number of electrons in a shell is 2n raised to the power of 2. The shells are K, L, M, N, O, P, Q, which means 1, 2, 3, 4, 5, 6, 7 respectively. Now we go to the number 2. Number 2, which is the subsidiary. It is also called azimuthal quantum number. It shows the energy sublevels in each shell. It ranges from 0 to n-1. It is represented by L. So now let's go to number 3. So this is the subsidiary. Then the number 3 is magnetic. It is represented by M and shows the orientation of the shells. It ranges from L through O to L. It ranges from L through O to L. You get? So number 4 is spin quantum numbers. It shows the spinning of the electrons. It is represented by S and has value of -half and half. -1/2 and 1/2. Arrangement of electrons in an atom. It is governed by 2 laws. Number 1 is Hund's law. It states that electrons filling an orbital will first exist singly before pairing. Number 2 is the Pauli exclusion principle. It states that not more than 2 electrons will occupy an orbital, and these 2 electrons must spin in opposite direction. So this is a photo of what I'm saying. This is a photo of what I'm explaining. Look at the first one, this hydrogen. At first it singly exists. Then before this carbon side, then it started pairing, and the pair must face, like, it must be opposite in direction. You get? It must be opposite. That's what Pauli exclusion said. Why the Hund's law said it must exist singly. Then this is modern electronic configuration. You can see SPDF. So that is for that one. Then the subshells, the number of orbital, the maximum electrons, that is the XPDF. You can see everything is just there You can still take screenshot of these things so that maybe later you can learn to your own. And you note the D block elements are transition elements, 4F are lanthanide, while 5F are actinide elements. Take note of this particular one. Now, atomic number is the number of proton in the nucleus of an atom. Z represents atomic number. Mass number is the sum of proton and neutron present in the nucleus of an atom. A represents the mass number. Isotopy. Isotope is a phenomenon in which atoms of an element possesses the same atomic number but different mass number due to difference in the number of neutrons. E.g., oxygen that has the same atomic number 8 and different mass number 16 and 17. Oxygen, that is for oxygen. Then you take note, it is isotopes that makes relative atomic masses of an element to have decimals in points. Decimal points in them. An atom which exhibits isotopy is termed isotope. An atom which exhibits isotopy is termed isotope. So now we go to the periodic table. They say the latest periodic table was the arrangement of elements in the increasing order of their relative atomic mass. Then the modern periodic law states that what the property of an element is the periodic function of its atomic number. So this is the modern definition, that the properties of an element is the periodic function of its atomic number. So this photo is not that clear, but group 1 are the alkali metals except hydrogen. Group 2 alkali earth metals. Then group 7 they are halogens or salt formers. Then group 8 they are noble gases or rare gases. Note, transition elements are found, or transition metals are found between elements in group 2 and 3. Characteristics of transition elements: they have variable valencies, they have high melting point, they are paramagnetic, they change color in solutions. Then we go to the periodic trends. Number 1 is ionization energy. It is the energy required to remove electrons from a gaseous atom to form an ion. It increases along the period but decreases down the group due to increase in screening effect. This is ionization energy. The energy required to remove electrons from a gaseous atom to form an ion. Electron affinity is number 2. It is the energy change that occurs when electrons is gained by a gaseous atom to form a negative ion. It increases along the period but decreases down the group. Note, electronegativity is the same as electron affinity in the periodic trend. So we go to number 3. Number 3 is what? Number 3 is atomic radius. Atomic radius, what is atomic radius? Is the distance between the center of the atom to the outermost shell of the atom. It decreases along the period but increases down the group. The distance between the center of the atom to the outermost shell of that atom. You get. So number 4 is what? Effective nuclear charge. They said it is the pull which the nucleus exerts on the shells of electrons outside the nucleus. It increases along the period but decreases down the group. This is for effective nuclear charge. So now we go to number 5, electropositive. It is the tendency whereby atoms, usually metallic atoms, lose electrons to be positively charged. It increases down the group but decreases across the period. Number what? Let's go to the next one, the next slide. So we have come to the end of today's class. Do not forget to click on the subscribe button and turn on the notification bell so that YouTube will recommend this video to many people interested in learning with Miracle. So guys, thanks for watching. Bye. I love you all. God bless you.